Alright, we're in 2-3 in Advanced Algebra 1, Advanced Algebra 2, and today we're continuing with piecewise defined functions. The difference today is it's not going to be a step graph because as you look at the function that we're used to, this guy, he's a horizontal guy because he doesn't have any x's involved with him, but this part of the function right here, since now there's x's involved, it's going to become an oblique line in that situation. And then you could even have parabolas, like part of a parabola, part of any kind of graph that we're used to. But this is going to be a horizontal line. This is going to be an oblique line because it's going to be like y equals 0.80x plus 5, and etc. So let's just kind of dive in here and see what this story is all about. It says Steve uses his car to drive passengers around town. He charges his customers $5 for the first 3 miles or under. Right? So if you get a ride from Steve and you go 3 miles or under, it's going to cost you $5. If a passenger travels more than 3 miles, Steve charges 80 cents for each additional mile. Now the difference between this and what we did last time was now it's 80 cents times the number of miles, like 1.1 miles, 1.2 miles, I should say 3.1, 3.2, 3.3, like each tenth of a mile, each fractional mile actually counts towards your fare right here. So you can see that where x is the number of miles driven, you're taking 80 cents times the number of miles, and you're adding that $5 if x is greater than 3. So what we've got is we've got two different functions here. I'm going to kind of color them to make them easier to talk about. We've got the green piece right here, and we've got the red piece right here. And notice each piece has to deal with how many miles have been driven. We only use the green piece of the function if the number of miles is greater than 0 and less than or equal to 3 at the same time. It'll cost us $5. If we go over 3 miles, then we have to use the red function to deal with that situation. So, 3 different people here. Yolanda, she rode for 4.25 miles. Bing, right here. It says find C of 4.25 because this function's name is C. So we just got to put 4.25 in for x, but we got to realize which part of this function, which piece are we in? Are we in the green piece or are we in the red piece? Since the x value is greater than 3, we'd have to go into the red function in this situation. So it's pretty simple right now. We just go ahead and punch this straight into our calculator. I need to put 4.25 in for x into the red function, so I'll take 0.80 times 4.25 and add that 5 to it. And it would cost Yolanda $8.40 for that ride right there, so we'll put that in blank A, $8.40. The trick to this is just figuring out which piece of the function you need to be in. So Jackson, he rode for 2.3 miles. And is he in the green piece or is he in the red piece? Well, since 2.3 is between 0 and 3 in this green zone right here, it's going to cost him this much, so you'd put 2.3 in for x. Well, there is no x because the price of that ride is always $5. It's like because that's within the first 3 miles of that situation, so it's going to cost Jackson $5 to ride that ride. And then Rick rode for 18.1 miles in Steve's car. Find C of 18.1. Well, where would 18.1 go into? Into the green guy or into the red guy? I mean, it's pretty obvious that since it's bigger than 3, 18.1 is bigger than 3, we got to go into the red one, so we'll punch in 0.8 times 18.1 and add 5 to that. So a nice little piecewise function. We're just learning how to understand and read them, and we'll kind of graph them later today. So that would cost whoever this person was again, $19.48 for that ride in that situation. It was Rick. Let's try another one. Something you should know quite a bit about in Kansas is the wind chill. You know, it gets pretty cold in the wintertime when the wind's blowing. So we know what wind chill is. This formula down here below gives the wind chill factor when it's like 30 degrees out. So like if there was basically no wind, the temperature would be 30 degrees Fahrenheit. And then whatever the wind velocity is, that's V in this situation. This equation right here will give us what the wind chill temperature actually is. So let's look at our pieces here. You don't have to highlight them, I just like to. We've got 3 pieces in this function. So this guy, your restricted domain here says if your wind velocity is greater than or equal to 0 or less than 4, right? The temperature is going to be 30 degrees. So basically, if the wind's barely blowing, right, it's from 0 to 4, it's still going to be 30 degrees. Then here in the red piece, we've got this big old honker of a function in this situation, but that only works if the wind speed is greater than or equal to 4. So notice that the 4 counts in the red one, it doesn't count in the green one, and less than or equal to 55.9 miles per hour. So basically, this is the main function right here, because like when the wind is bigger than 4 and less than basically 60 miles per hour, that's the equation that we'll use in this situation. And then, you know, we've seen the wind get more than 60 miles per hour, or we'll call it 55.9. If the wind is more than that, then the temperature is basically going to be negative 6.5 degrees Fahrenheit. And it doesn't matter. It could be 100 miles an hour. It's just really never going to get much colder than negative 6.5 degrees. So again, we just got to figure out which function we're going into, the green, the red, or the blue. It says find the wind chill factor for a 30-degree temperature. I should mention that this particular function, this entire piecewise guy, only works if the regular temperature with no wind is 30 degrees Fahrenheit. Like if we were at a 60 degrees, you'd have a whole different function or something like that. So basically, it says find the wind chill if the wind is blowing 40 miles per hour. So we got to figure out which function we're going into, red, green, or blue. 40 falls into the red zone. So let me grab Yon calculator right here, and I'm going to put 40 in to this guy right here. I'm just going to type what I see. So 1.259. I'm going to put the 40 in parentheses. It's always a good idea to substitute stuff in parentheses. Minus 18.611 times the square root of 40 plus 62.255. Punch that in, and it's about, let's see what they tell us to round to. They do not. So why don't we round to the nearest whole number? Like when we're talking temperature, it kind of makes sense. So that'd be about negative 5 degrees Fahrenheit. Don't forget to put the Fahrenheit because you can measure stuff in Celsius. And it says find the wind chill if the wind is 65 miles per hour. So if the wind's blowing 65, we've got to figure out which one of these pieces we're going into. 65 is the number you're trying to see which one of these domains it fits into, and doesn't it fit into the blue one? Isn't 65 greater than 55.9? So there's no real calculating to do. It is just literally negative 6.5 degrees Fahrenheit. Well, since they have a tenth of a degree here, why don't we call this negative 5.1 degrees Fahrenheit then, since we'll round that to the nearest tenth. So we'll go back and fix that. And then the last part, part C, it says find, or I guess there's a part D, find the wind chill if the wind is blowing 2.5 miles per hour. So 2.5, we've just got to figure out which piece, and doesn't that go into the green guy? And the temperature would be 30 degrees Fahrenheit. Basically, that little bit of wind speed, 2.5 miles per hour, didn't affect our temperature at all. And now, part D says, here's the graph of that. Like, if we graphed each little piece, here it is. It says, find the domain and range in interval notation. So, let's do the old kind of straight edge test with a little bit of common sense also. We could do the straight edge test a little bit, but we got to kind of think this, because this is a story problem. We got to think about what really counts for the domain and what doesn't. Or you could actually just realize that this is the entire domain right here, but the graph kind of helps us figure out what it is. So if you go from left to right, notice the blue part is the graph. It's not over here in the negative zone. We're doing domain, so we're talking about the x values right here. So it's 5, 10, 15, 20, all the way to 0. Remember, if you labeled your axes or anything like that on a graph, this is your wind speed. And it's like totally impossible for the wind speed to be negative. You can't have negative wind speed. So that's why they say here your wind velocity, your wind speed's got to be greater than or equal to 0. It can be 0, right? You can have no wind whatsoever, or greater than 0. So for the domain, we can start at 0. It's totally included. And then if we work our way to the right, you notice there's like no gaps or anything in this. It's like touching and touching and touching and touching and touching. Then it kind of stops here at 70, but really the wind can blow more than 70 miles an hour, so it's going to go from 0. We'll just go to positive infinity, even though you and I both know it's not really, the wind's not going to blow infinity miles per hour, but it's just going to keep on keeping on. You can see that in your domain. It's like it starts at 0. It was included. It went to 4, and 4 wasn't included, but it starts over at 4, and that was included, so that like filled in the hole there. Then you went to 55.9, which that's included, and then it went greater than 55.9, so basically from 0 included to infinity. The straight edge test, though, is really going to help us out for the range a little bit. It's like that's our y value, so we go from low to high. And as low as we can go, I'm down here at negative infinity. It's like the temperature should not reach negative infinity. That would be very, very cold. But I don't start touching the graph here until this blue guy, which is this part of the actual function right here, at negative 6.5 degrees Fahrenheit. And remember, it was going to stay constant, nice and horizontal. So the range started at negative 6.5, as low as it could possibly get. And then how high does this bad boy ever go? Well, just to 30. Right, so to 30 included. That could be the temperature, and that's it. So a little domain and range for us. Now let's actually make some graphs.
Defined. Easier than you think if you can follow these baby steps. This says f of x will equal x minus 2 if x is less than negative 1. But here's a whole other situation. This function is going to equal x plus 3 if x is greater than or equal to negative 1. So we've got two different pieces that we're going to graph. Sound all right? Here's what I want to do. Where you got space, you know, probably to the right of your grid, like right in here, let's make a little baby table. Let's do this. Let's highlight this guy one color. So grab a highlighter, and let's highlight this guy a color. Red is what I chose. And what I'm going to do is make a little table of values. I'm going to call this y equals x minus 2. Like this is x minus 2. This is what the function equals, and we're not so comfortable with f of x formation so far. I'm just going to call this y equals x minus 2. I'm going to make a little baby table right here. Little baby table of values. Cool? And all that we have to pay, I shouldn't say all, what we have to pay the closest amount of attention to is what our restricted domain is. They are telling us specifically what x values you need to use. Doesn't this thing have something to do with a negative 1 right here? So I'm going to start with a negative 1, and I need to realize this. This is going to be weird at first, just hang with me. But since there's no equal to bar on this, does negative 1 actually even count in that domain? So when we graph it, we'd put an open circle on that, like that open dot kind of thing. So I do this, meaning there's an open dot around negative 1. Cool? Now we're going to choose other x values that fit into this domain. Aren't they supposed to be less than negative 1? So what's another x value that's less than negative 1? How about let's just go with negative 2? Would that be okay? What's another one? One more. And after this, it'll be pretty simple to graph it because it's just a line, right? But we just needed to figure out where's it going to start from. It's going to go from negative 1, which is not included, and going to get smaller. You cool with that? Let's figure out some y values, though. It's going to be a waste of time to probably use that table. It's just too much punching. Let's just use our brain. If we put negative 1 in for x, what's negative 1 minus 2? Now, you can use a calculator, but I'm saying don't punch it in and try to go to the table of values. Too much time, right? So what'd you get? Negative what? Negative 3. Is that cool with you? Let me switch back to red. Do it all in the same color. Negative 3. If I put negative 2 in for x, what would I get? Negative 2 minus 2 is negative 4. And if I put negative 3 in for x, I would get a negative 5. Before I move on, are you cool with where those numbers came from? Now I'm going to go plot them. But realize that this point in particular has an open dot, not a closed dot. So I'm going to plot negative 1, negative 3 as an open circle right there. See how I did that? Negative 1, negative 3, but I'm going to make it an open circle. Awesome? Then I'm going to plot negative 2, negative 4, and that's a closed dot. And then I'm going to plot negative 3, negative 5. And that's a closed dot. And do you see how if I was to start to connect the dots, isn't it supposed to go less than negative 1? You with me on that? So let's take our straight edge and realize that we want to go less than, I'm going to use red, sorry. We want to go less than -1 and put an arrow on that bad boy going this way. It's like a line, but we're only taking a piece of that line. That's that entire line y equals x minus 2, but only from -1 and to the left of it. Y'all cool with y connected to the left and not connected to the right, because these are all the x values that are less than -1. Take your same color highlighter, whatever you highlighted this line, and don't highlight the open circle because that gets it too confusing. Just that little line thing, just highlight it that color. Okay? Cool, but make sure I can see that that's an open circle. That's going to be the most missed part of these deals, is open dots versus closed dots. Okay, now new piece, right? It's green time. Let's highlight this a different color, whatever different color you got right here, and let's make another baby table. So I'm going to call this green, and I'm going to write y equals x plus 3. I'm putting a y equals in front of it. Okay, so far? Make a little baby table. It seems really like childish to make these tables, but they help. They tremendously help. We've got to pick the right x values, though. We're going to start with whatever this guy restricted us to. At -1, question is, does it count or does it not count this time? It counts because they have an equal to bar. You with me? And this is greater than -1, so let's start picking some numbers greater than -1. Next one is 0, and then how about a 1 after that? Sound cool? So far, so good. Now let's substitute these numbers in and see what we get. If we put -1 in for x into this green guy, -1 plus 3 is 2. Putting 0 in, we get 3. And putting 1 in, we get 4. Are you feeling pretty comfortable with where those numbers came from? Let's plot those points. -1, 2. Is it an open dot or a closed dot? Closed dot. And then 0, 3. And then 1, 4. And then that kind of tells us which way this dude's going. It's going to keep on going forever. So, straight edge. And then highlight it that same color. And that's it, baby. That is that piecewise defined function. It's a function because it'll pass the vertical line test. And it seems weird, but will it pass the vertical line test if you put a vertical line right here? Because it goes open dot and closed dot, right? It doesn't count. I put my vertical line in the wrong spot, sorry. But if I put a vertical line right here, this passes it because it only went through the graph once at the green dot, not at the red dot because the red dot doesn't count, correct? So it does pass the vertical line test. You with me on that? Okay? I want to do the easier part first. Let's fill out these f ofs. And here's where I think the highlighter makes a big, big difference. Because these are all x values, correct? You have to pick which one of those functions it should go into. Should it go into my red one or should it go into my green one? Well, I'm going to pick on my red one first. I'm going to grab my red highlighter and say all the x values have to be less than -1, and -1 doesn't even count, correct? Is this x value less than -1? Nope, that's a 0. It's not less than -1. Is this one less than -1? I'm going to highlight that red, and I want you to highlight it whatever color that dude is. Is this one less than -1? Nope. Is this one less than -1? You see how this f of -5 is the only one that fits into the domain of this situation because it's a f of x, and that's the x value right there, and this is the only x value that fits in there. So all my other dudes are green, green, green. Cool? Now I'm going to substitute them in. I know this dude's going into the green equation. If I put 0 in for x, what's f of 0 going to turn out to be? 3. You're just putting 0 in for x, and 0 plus 3 is 3. With me on that? I'm going to jump down. I'm going to do all my greens at one time. All right, all my greens at one time. Then I'm going to put 1 in. If I put 1 in for x in the green equation, what would I get? 4. And if I put 4 in, wouldn't I get a 7? You with me on that? But I got this one blank yet because it was a red guy, so I got to put -5 into the red equation because that's which domain it belongs to, and what's f of -5 going to evaluate to be? -7. Is that okay for our very first problem? Now, the hardest part. Domain and range. And we're going to do it in interval notation. That's the easier version of it, right? We want to try to keep things in interval notation when possible. Domain is x values. When you have a graph, you have to look left and right to do that, correct? left and right. How far to the left will my graph end up going? Negative infinity. How far to the right will it go? Positive infinity. But we've got this weird situation here. Is there any x values that just don't work? Like, what do you think? Like, could I put negative 2 in for x? Did I get a result? Could I put negative 1 in for x? Did I get a result? Not on the red one, but on the green one, did I? Yep. Was there any holes left to right? Was there anything that never got filled in? Let me give you an example of what it would look like if there was a hole from left to right. So if we graph something like that, you see if I look from left to right, there's a gap in here where there's no x values whatsoever. You kind of see that gap if I'm looking from left to right. Now I know if we go back here, there is a gap, but isn't that an up and down gap versus a left and right gap? You kind of know what I'm saying? Are there any left and right gaps between the red dude and the green dude? Yes or no? No. Meaning all real numbers work for our domain. That's tricky. We'll get better at it as we go. But how do we write that in integral notation? From negative infinity to positive infinity, my friends. Left and right is domain. You're looking for gaps. Are there any gaps? No gaps, left and right. You cool with that? Range is up and down. So first we start low to high. We always start low to high. How low will this thing end up going? How low? Negative infinity. So I know I can start here from negative infinity. Right? Now let's work our way up and see if we get to any gaps. Working up, working up, working up, working up. Boom! A gap starts here. Would you agree there is a gap right here? Starts right there. Where is this place y value-wise? Where is the y value of that? At negative 3. Does it count or does it not count? So that's a parenthesis. You with me? Then I've got to jump over the gap. So that's called a union right there. I've got to unite it with, as soon as I come up to, don't I have another y value starting here at 2? Does it count or does it not count? From 2, and then doesn't it keep going up forever and ever and ever? So you're looking for gaps, either left and right for domain or up and down for range. Okay? We will get better at that. Cool? Next guy. Got to erase this. Let's highlight the first dude a color, whatever color you want it to be. That highlighting helps. I'm a visual guy. You guys know if you had me for geometry, I'm a very visual dude. Let's make a baby table. Y equals. What will y equal for my red equation? What will y equal? 2x plus 1. Baby table, x and y. And we don't need a lot of stuff in these tables, just a little bit to get us started. What x value will you pick to start with for this first part? I would choose a negative 1. Does it count or does it not count? It's all about if this has an equal to bar. Does it count or does it not count? So I put a circle around that dude, meaning that that's an open dot. What's the next x value you would choose according to what this is telling us? Got to be bigger, so what do you want? 0, then how about one more? 1. Is that all right? Substitute those numbers in. Give me some y values. Excuse me. Negative 2 plus 1 is a negative 1. 0, 1. Right? And then this would be a 3. Is that what we got? Negative 1, 1, 3. I got a question for you. Do you know what the slope of this line is? Just by looking at it, do you know what the slope is? This is in slope-intercept. This is y equals 2x plus 1. We're looking right here. Do you know what the slope is? 2. Did each one of these go up by 2? All right, rise 2, run 1, rise 2, run 1. So cool. Let's plot negative 1 first. Open dot or closed dot? That's the real question. Open dot. The next plot I need to do is 0, 1. Right? Wow, amazing. Check this out. How did I get from here to here? I went up 2 and to the right 1. Isn't that the slope? Where's the next point going to be? It's going to be at 1, 3. Up 2 and to the right 1. That's all that is. This baby table helps us realize where we got to get started and which direction we got to go. You with me on that? So, mute. Cool with that. Then highlight that line that color, but leave the dot to where I can still read it pretty good. And now, let's do the other guy. Pick a different color. Whoa. I want to do this one the long way. Explain it the first time. Pick another color, right? So I got green. What would my equation be for this? Y equals whatever that is. -3, correct? Ta-da! How many variables are involved with that? 1 or 2? 1. Is it only a Y? What kind of line is that going to look like? Is it going to be horizontal, vertical, or oblique? That's a horizontal line. I want to show you the baby table. I'm not going to make you put it if you don't want to, but the baby table would look like this. We got to pick a Y value, right? An X value. Where are we going to start from? -1. And does it count or not count? Counts. Then I got to get smaller, right? So wouldn't that be -2, -3, and etc.? You with me? What's Y going to turn out to be? I can't even substitute it in. What's Y going to turn out to be? -3, -3, -3. That's what that means. Y equals -3, correct? The thing is, where does it start from? It starts at -1. So I got to do -1, -3, which wouldn't that be right here? Isn't that the point? -1, -3, correct? And then the other point was this guy and this guy. Shouldn't that turn out to be a horizontal line going this direction? So far, so good? We cool with why that's horizontal? It's just Y equals -3. Yes, no, maybe? Okay. Let's go straight to domain now, since we've kind of explained that. Domain is left and right. We're looking for gaps, left and right. We start from left to right every time also. Doesn't this dude start from -infinity? Correct? Now, if we move to the right, it goes to +infinity. But were there any gaps left to right in this puppy? There is not, because this guy ends at a -3 and this guy starts at a -3, correct? And this green dot fills that dude in, so our domain is from -infinity to +infinity. There were no left to right gaps, if you will. Now let's go domain, which is up and down. You have to start with as low as you go. How low does our picture ever go? -3, correct? Now let's just talk it out. So we're not going from -infinity. We're starting down here at -3. You cool with that? Then let's get higher. Do I have a gap to bridge? So my gap starts at a -1, correct? And then goes to infinity, correct? So I definitely know the second part. Here's my gap. I'm unioning it. My second part, I definitely know, goes from -1. Does -1 count or not count? So that's a parenthesis to infinity. Is everyone cool with this portion of it? This is just -3, correct? We cannot write that in an interval notation. We have to write it as a set, -3. It's the entire set, -3, and then we're going to union it with the entire interval of -1 to infinity. Okay? Highlight these. See which ones they belong to. Right? Grab one highlighter, highlight them all at one time, highlight the other ones. I'll pause the video and get that done. So I did my top one, which was red. Any number that's bigger than -1. 0 is bigger than -1, 1 is bigger than -1, and 4 is bigger than -1. Correct? The only one that didn't fit was that second dude. Now let's evaluate each one of them. So my red guys, f of 0 goes in this top one. If I put 0 in, wouldn't a 1 shoot out of that situation? Finish those up. You cool with 1, 3, and 5 for those top guys? You know, that would, like, I lift this gap here, though. What is this guy? What is f of -5 going to turn out to be for a y value? Isn't y equal -3? F of 4 is 9. Yeah, 8 plus 1. My bad. Thank you. 9. Sorry. And then this guy's going to be -3, though. That's what I was talking about. Does that make sense? It's like, oh, there's nothing to substitute in for. That's because y equals negative 3. You with me on that? Also, a piecewise, 2 pieces, correct? Only 2 pieces. Now, 3 pieces, correct? So highlight one of them a color. The top one, a color. Let's make a baby table. Use the right color. So our first x value that we pick is negative 4. Does it count or does it not count? Doesn't count. Open dot around it. Then what's the next x value that I want, my friends? Something smaller, because that's what this is saying. You want something smaller than it. So negative 5 and then negative 6. Substitute those numbers in and give me some y values. Sounding good with those? Negative 2, negative 3, negative 4, is that what we got? Let's plot them. Negative 4, negative 2, you've got to watch to see if that's supposed to be open or closed. And it's open, right? Then the other one is negative 5, negative 3. And then after that, I know my slope is 1. If you wanted to just count by the slope, it's rise 1, run 1. Or could you go down 1 to the left 1 also to get that done in this situation? Plotting the points to me is an easier method than trying to count that slope, because it's like, which way am I supposed to go? Which way am I supposed to go? Right? Just make a little baby table, and it'll tell you which way you're supposed to go. Okay? Another color. The colors make a tremendous difference. You got to trust me on someone who's made many of these. The highlighters help me a bunch. So, another baby table. I'm doing green this time. Y equals negative x. So my first x value. Ooh, brother! Look at this restricted domain. This says x has to be greater than or equal to negative 4, but at the same time less than or equal to 2. We got 2 boundaries. Small to big is how it's always written. What's our smallest boundary going to be? Negative 4. Right? Does it count or does it not count? It counts. And then I'm going to put another number. Is 0 in this range? What do you think? Like, I don't have to put them all. I just need a few numbers to help me out. Is 0 in the range of negative 4 to 2? So I'm going to put a 0 in there. And then I'm going to put one more point, a very, very particular point that has to be there. What has to be there? 2 is the other boundary. These 2 brothers are very important. They are the 2 boundaries to this domain. You with me on that? Does 2 count or does it not count? Counts. So let's plot these bad boys. Or sorry, figure out our y values now. So negative 4, if I put negative 4 in, it's just y equals negative x. So what would that turn out to be? Positive 4. If you put a 0 in, wouldn't that be 0? If you put a 2 in, that would give you negative 2. Cool with that? Let's plot those points. Negative 4, positive 4 would be way up meow. And it counted, so that's a solid dot. 0, 0 was on there. And 2, negative 2 was on there. Now when you connect, do you have to stop? It's just a segment now, right? This is not a ray in any situation. It is a segment. So we have to just connect that little dude together. It's got 2 endpoints. And they both counted. Now, I want to do for future purposes, was this point even necessary, this 0, 0? When it comes to the baby table, for a segment like this, you only need 2 numbers. This guy and that guy. Those are the only 2 that really matter. Aren't those the ends of them? So, let's do our final guy. Third color. Baru. And what's the first x value that you would pick in your baby table for this blue situation here? I would pick a 2. Does it count or does it not count? And that's where we get into trouble because we're so far into the problem already, we kind of forget about that count versus not count. We got an open dot around 2, and then 3, 4, because they're getting bigger, correct? So some points, that would become a 6, then how about a 4, my bad. 4, then a 6, then an 8. Wait a minute, it was times 3. I, for some reason, thought it was times 2. It would be a 6, then a 9, and then a 12, correct? My bad, I totally brain farted on that. Open dot at 2, 6. And then 3, 9. And that's all I can plot, brothers and sisters. Make your arrows go through the grid at all times, or your lines go through the grid, and put an arrow on them also. What I want you and Pal to do is try the domain and range on your own and see how well we do. Domain and range. So our domain was all real numbers, which we'll say like this. Now let's try that for the range again. Let's do, except it's going up and down, right? So let me use my little test. Start low. How low will this thing go? I know I'm starting at negative infinity, right? And I'm going to keep working my way up, keep working my way up. Oh, there's a spot, so I'm going to go this way, because aren't we going low to high? Does it continue on? If I would have drawn that a little bit better, does it continue on from that point? Yep, so I'm keep going up, keep going up, keep going up, keep going. Oh, there's a spot. I'm going to draw this. Is there a gap in between there, right? So let's realize what we've got so far. Didn't we say we went from negative infinity to this gap, which is where at? 4 on the y-axis, right? We're doing y values. 4, does 4 count? Boom. Now I need to bridge the gap with a union symbol, and where will it restart from? 6 non-included is how you say that. It's either included or non-included. And then to infinity. You kind of with me left to right for a domain, up and down versus range. Cool? Let's fill these out. Highlight them. We got 3 different options now to see where this thing goes into. Here's what I'm going to do first. I'm just going to pick on one of them. I'm going to pick on my red guy. Say I need numbers less than negative 4, and negative 4 doesn't even count. So, you cool with that? This is the only one that's less than negative 4. Cool? Then I'm going to grab my other middle color of whatever that is. Actually, it might even be easier to go to the third one, right? Wouldn't that be kind of easier, in my opinion, the third one? Because aren't those just numbers that are bigger than 2, right? Numbers bigger than 2, and 2 doesn't count, so nope, nope, yep. Isn't that number bigger than 2 right there? And everything else has got to be that middle dude. Make sense? So what color was it? It was green. And then evaluate. Evaluate the function at those particular points. You will most definitely probably, yes, that's a phrase. You will most definitely probably see questions like this on the state assessment. Not graph it, but they'll give you a piecewise function and ask you to evaluate the function at a certain point. You have to find which set of domain does that belong to, so I can substitute that number into that particular point. So f of 0 turned out to be, with a pen, 0. F of negative 5 turned out to be negative 3. F of 1 turned out to be negative 1, and F of 4 turned out to be 12. We cool with that? Let's give it a shot on the next bad boy, right? 3 different situations. Let's start with the first one. Highlighted a color. Oh, Daddy likes this one. Is that horizontal? What do you think, yes or no? If you don't feel it's necessary to make a baby table on these horizontals, you don't have to. If you want to make a baby table, make a baby table. But let me show you how to do it without making a baby table. It's a horizontal segment. Y equals 3, correct? The thing is, where does it start from? It starts from 4. You with me? Does 4 count or does 4 not count? So you got to go to 4, 3, and put yourself a spot. X is 4, Y is 3, is what that says. Now, which way is it going to go if it's X is greater than 4? It's horizontal, so which way is it going to go? To the right. Let me use green, so that'll match my color. to the right. If you felt more comfortable making a baby table, you make that baby table. I got absolutely no problem with that. But on the horizontal dudes, you know, it's a horizontal segment. Okay? Middle guy. How many boundaries do we have for it? 2. You do need a baby table. It will save your life to make a baby table. So, y will equal negative 2x plus 3. And in that baby table, there are only 2 points that stinking matter. What are those 2 x values? Negative 1 is one of them, and 4 is the other one. Do either one of them count? They both count, correct? They both count. Figure out their y values. X was negative 1. This will turn out to be a positive 2 plus 3 more is a 5, right? And this would be negative 8 plus 3, which is how much? Negative 5. We cool? Let's plot those 2 points. They count or not count? I can't remember. Count, so solid dots. Negative 1, 5. 4, 5. Yes, 4, negative 5. Thank you. 4, negative 5. Appreciate that. Right? Connect those 2 dots together, but it's a segment, right? It is a segment. And then one final guy. One final guy. No, the sound didn't go out. I'm just whispering. Video people. Sorry. They're like, I can't hear you. That's because I'm whispering. Just substitute these in. Negative 3, negative 4. Good? And then I'll plot them. So I'm kind of just talking to the video people now, class. You can just keep on keeping on. If you have a question, holler at me. Did I do something wrong? Are we okay? Okay. If you got that, domain and range it. We are from negative infinity to positive infinity. There. No, it won't be. It will not always be. I'm glad you asked that. It will not always be negative infinity to positive infinity. Okay? Range, up and down. You always start low to high, because that's how this is written. Isn't it written from smallest to greatest, right? You go low to high. So low, isn't it down here at negative infinity? Correct? Follow this guy up, follow this guy up, follow this guy up. There's a spot. Does it get filled in? Yeah, it connects me over to that red guy, right? It goes over to the red guy. Even though that's not like an end to that red guy, doesn't it go over to the red guy? Then, working my way up, working my way up. Whoa, there's the green dude. But can't I still go up on the red guy? Can't I still go up on the red guy, up on the red guy? And there's a critical spot. Does it go any higher than that? So it's got a height maximum, correct? At this 5. Does 5 count or does 5 not count? So we started how low? And the only place where we got to a height problem was at 5, and it finally counted, so we'll do it like that. This dude didn't even come into play, right? Because the red guy trumped the green guy. Okay? Fill out those now. Pick on the green one first. Anything bigger than 4? Is there anything bigger than 4? Well, that's a 4, but it's not bigger than 4, correct? So no greens. I'm going to go straight to blue then. Anything less than negative 1, which is this guy, right? That's less than negative 1, correct? Everything else is going to be my red guy. So put 0 in, I get a 3. Putting 1 in, I get a negative 2 plus 3, which is 1. Putting 4 in, I get negative 8 plus 3, which is negative 5. Got to go down here and put 15 plus 5, which is, oh, it's negative 5, my bad. So negative 15 plus 5, which is negative 10. Nice? The way I see it, we're feeling pretty decent with it. Perfect? No. Decent? Yes. Now, let's go backwards. They give you the pieces, and you have to write the little functions. Very easy to do. Very, very, very easy to do if you go one step at a time. First thing, there's 3 guys. Highlight them colors. All different colors. Would you be comfortable to start with that every single one of these is linear, right? There's no parabolas, none of this crazy stuff. They're all going to be linear situations. We need 2 things to write the equation of a line. We need a slope and we need a y-intercept, correct? That's all we need is a slope and a y-intercept. So here's what I want us to do. Whatever this green one is, whatever color you highlighted it, put a little number 1 right by it and circle it. And let's go down here and let's do all the work for number 1. Look at your scale that this is going by. Isn't this going up by 1s? 1, 2, 3, 4, and 1, 2, 3, 4. Let's see if we can find the slope just by counting rise over run. Would that be okay for us? Is it positive or negative, first of all? What's this thing doing as you look from left to right? Going up or going down? Going up. I know that arrow's going down, but what's this line doing as we look from left to right? It's going up. You with me on that? So let's find some nice, neat points. What do you think about that? Is that a nice, neat point right there? And where's another nice, neat point? Maybe like right there. Does that look nice and neat? Let's count. Rise 2, run 1. What's my slope? Put that down in this information. M equals 2. You with me on that? We just figured out for this green guy, which I should use green. Sorry, let me start over. That the slope equals 2. So step 1, M equals 2. Cool? Y-intercept. Can we see a place where this dude crosses the y-axis at? It crosses it right there. Nice and neat. Isn't B equal 3? You with me on that? Can we write the equation of this line knowing a slope and a y-intercept now? So right here, I'm going to do y equals 2x plus 3. And that segment is complete for what we want to do right now. We'll put it all together at the end. Okay? This is the equation if this thing would go on forever. Sound cool? Then I'm going to go to step 2 here, which is this dude. Put a little 2 by it, separate my work, and put a little, here's segment 2. Sound okay? Yes, no, maybe? So, I need a slope first. Is it positive or negative? Look at this guy. Which way is it going from left to right, up or down? That's going to be negative, correct? I know my slope. Can I count? Down 1 to the right 1. What's the slope? It's not 1. It's negative 1. Come on, folks. Sign first, then count. Rise over run. Y-intercept. I don't see it. So, there's some things you could try. Maybe we could count to it. Couldn't I go up 1 to the left 1? Also, wouldn't that be where it would be if I kept going with my slope? Isn't it like down 1 to the right 1, down 1 to the right 1, down 1 to the right 1, or up to the left 1, up 1, to the left, up, rise over run. So up to the left, boom. Isn't that where the y-intercept is right there? Happened really nice and neat. Where is that at? B equals 2. Everyone cool with where I did that? I counted from the end point. I went up 1 to the left 1, which is still a slope of negative 1. And now this guy is y equals negative x plus 2. So far, so good? So far, so good? Number 3 is what kind of segment? It's actually a ray. What kind of ray? Horizontal, vertical, or oblique? Horizontal. You know all horizontal equations start with what? They're horizontal, correct? Y equals. What does y equal in this guy right here? 3 every single time. Done. Got them all. All these little dudes right here. Got them. Now it's time to make this thing. F of x equals. And then make this bracket as best you can. We're going to put those 3 dudes in there without the y equals now. We're going to drop the y equals, and we're going to go one at a time. The first one that we got, wasn't it 2x plus 3? You with me? So that's going to go up here. But wait a minute. We have to restrict the domain on it. What is domain? X's or y's? So if. Now let's look at the green guy. And x values. Isn't this a very critical point on that green guy right here? What is the x value of it? This point. Y'all cool with that x value being at 1, right? And where did this ray go in relation to it? Less than or greater than? So we want to say if x is less than, should I put an equal to bar or not put an equal to bar? That's an open dot if x is less than -1. That was what that green part was. Yes? That's a positive one. Thank you. My bad. I don't know what I was saying -1 for, but positive one. This guy right here, this green ray, is the equation f of x equals 2x plus 3 only when x is less than 1. Okay? Middle guy, red, we put its dude right here, -x plus 2. How many endpoints does the red thing have? 2. That's that compound inequality. And it's all about x values. What is the x value of the farthest left guy right here? Because we go from small to big. X value. 1. Then symbols point to the left every single time. Is there an equal to bar at 1? X in the middle. Symbol point to the left. There is an equal to bar. What's the other x value of this guy? 2. Do you see that the x values were from 1 to 2 included in that situation? All the x values were greater than or equal to 1, but at the same time less than or equal to 2. You cool with that? Third guy, what are we putting right here? 3. That's it. Right? 3. If x is what? Greater than how much? Oops, that's not a greater than symbol. Greater than how much? 2. Should we have put an equal to bar on it? That's got an open dot. One more. Highlight them. I try to be consistent with my highlighting too. I always go in the same order. Like if my farthest left one was a green over here, I want my farthest left one to be a green. I try to do the same order each time. That's just me. Whatever works for you. And now we're going to step it up. Take that first one that we got. Always work from left to right. That's just how we do things here in America. We work from left to right. Put a little number 1 next to it up there, and put a little number 1 down here for our work. And this is what I'm going to require from you. You need to look at the scale first on this graph. Are they going by 1s? They're going by 2s, correct? I don't want you to count slope if they're not going by 1. It's a little too complicated for us. I'm not saying you can't do it. We're not going to count rise over run when they're not going by 1s. You with me? So what I need to do is find the slope between 2 points. I need 2 points first. Would you all agree that this is a point on the green dude? Even if it's not even filled in, even though this guy is filled in, even if it wasn't, isn't it like a point right there? Where is this? It's kind of weird. Isn't this -2 right here? So where's this at right there? I need a point at -3. Need to write these points down. And what's the y value of that point? -1. Y'all with me on that? I need one more point. Looks to me like this would be a decent point to choose right there. Where is that point? -6, 0. And double check you got the negative 6 and the 0 in the right place. Because if you find the slope wrong, everything's going to be wrong on this. Cool? Find the slope between those 2 points. Show me that little work that I required you of last chapter. Should it be positive or negative? I double check that when I'm done. It's like I got a negative 1/3. That thing should be going down from left to right. Isn't it going down from left to right? Now I need the equation. I don't have a y-intercept, and I sure as heck ain't going to try to count and guess that. Can we use point, slope, form to figure out how to write this equation? Pick a point out of these two. Which one would you choose? The one with the 0 in it would be a great idea of how to choose it. And let's do point, slope, form. You'd get y minus 0 equals the slope of negative 1/3 times x plus 6 or minus 6? Plus 6. Okay? There are some of you that didn't realize that you have to distribute this through. Folks, I know we made some mistakes last chapter. It's time that we got to correct those mistakes. That's how algebra works. We learned something so we could use it in the next chapter, so we could use that in the next chapter, so we could use that in the next chapter. Let's distribute. First of all, you know that y minus 0 is just going to turn out to be 0. Negative 1/3 times x is obvious. This guy, negative times positive, will turn out to be this wonderful number goes into that number, right? How many times does 3 go into 6? Twice. Take that times the numerator and get a 2. There's our equation right there. Y equals negative 1/3 x minus 2. That's for that first guy right there. Okay? Call this brother number 2. I like that one. I like that one a lot. It is horizontal. Get me an equation for this red segment that I have right here, which is horizontal. What you got? Y equals 2. No work needed on that. It's a horizontal segment. Excellent. Next guy. I need 2 points again. Let's pick this point since we know for sure. Where is this particular point located at? 1, 3, right? And then it looks to me like this guy is a nice, neat point. Sometimes they're not that nice and neat. You're just going to have to do your best guess at the weather right there. That to me looks like it's at 2, 6. Is that right? I'm standing too close. 2, 6. Is that right? Yes? No? I'm asking. Okay. What do you need to do with those 2 points? Find the slope. Notice how I label my work also. I put m equals to start with. Use point slope form to write the equation. So I'm going to choose this one. Don't have to, but I'm going to choose that one. Y minus 3 equals the slope of 3 times x minus 1. Distribute the 3 first. Y minus 3 equals 3x minus 3. Correct? Then this caught us on a lot of people's tests. How did you get that over there? How do you get that over there? How do you get it over there? Add it. What's a negative 3 plus 3? So don't put plus 0. They cancel each other out. All right, y equals 3x. Good deal? Now let's set it up. We got all 3 pieces, so let's set it up. F of x equals big old weird bracket thing. Try your best to make it. Top guy in red. Sorry, it's a green one. It's my green piece. I got negative 1/3 x minus 2. Correct? Restrict the domain on that piece for me. What is the restricted domain? Give it a shot. If x is, first of all, would you agree that we're going less than? Correct? Should I have an equal to bar? Yes. And what is the x value of that particular critical point right there? Negative 3. Second piece, in red, what goes here is a 2. Correct? Because that's what this was. You just dropped the y equals part. If, don't I have two boundaries on this bad boy? That's the double inequality. Smaller x value number on the left. What is that? Negative 3. Symbol points to the left. Do I need an equal to bar? Nope. X goes in the middle. Symbol points to the left. I also do not need another equal to bar for that endpoint. What's the x value of that? 1. And finally, my blue piece was 3x if x is what? Greater than or equal to 1 or 3? X value, not y value. 1 or 3? 1. Be careful. I know people are looking at that point and they see an x value of 1 and a y value of 3. It's all about x. It's domain, it's domain, it's domain. Cool?